Hi, everybody. This is Dr. Nigro with a Chemistry Notes screencast. This screencast is the second in the series dealing with mole conversions. This one's going to focus on moving back and forth between mass and moles. So if you're looking for information on moving between particles and moles, you need to go find the screencast that deals with Avogadro's number and how to make that conversion. This one is going to deal with mass. Okay, so can we measure a mole in the lab? All right. Do we have some sort of tool that allows us to measure that? All right. Well, remember, a mole of any substance contains 6.02 times 10 to the 23rd particles. All right. And that the particles can be atoms, they can be molecules, they could be protons, neutrons, electrons, something small. All right. But if we wanted to be able to measure a mole, we need something that could count that high. And that's really difficult for us to have in the lab. It would take a very long time to count 6.02 times 10 to the 23rd particles out. All right. So can we measure a mole in the lab? The answer to that is no. All right. We cannot measure a mole because we don't have any tools to do that measurement. All right. Instead, we choose to something that we can measure. So mass is something that we can measure, right? We can use a balance, right, to measure the mass of some object. And most chemistry labs are going to have a balance. So it's a pretty good choice as the way to measure the quantity of something. All right, so we're not going to focus on the mole in terms of measuring. We're going to use the mole as a way to move between measurements. All right, so before we can measure the mass of something, we need a way to equate the mass of an object to moles of that object. All right. So we use Avogadro's number to do that for particles. All right. When we do that for mass and moles, we're going to use something called the molar mass. All right. So the question is, what is that? All right. If you look on the periodic table, you'll see a number underneath the elemental symbol. It's usually a decimal of some sort. And what that tells you is the mass of one atom of that substance. All right, so for example, one atom of carbon has a mass of 12.01 atomic mass units. All right, now remember the atomic mass units, it's a fuzzy kind of unit. It's another one we don't measure in the lab because it's really hard to isolate a single atom of something. All right, but instead we can scale that up. All right, so if we multiply that one atom by Avogadro's number, so we multiply this by 6.02 times 10 to the 23rd, all right, then what we have is 1 mole's worth of carbon atoms. And what we find is the mass of that mole's worth is 12.01 grams. All right, now the gram is something that I can measure in the lab using a balance. All right, so the molar mass is the mass of 1 mole of any substance. All right. So the periodic table, that mass value that's under the elemental symbol doesn't have a unit because you really can think about it in two ways. You can think about it in terms of one atom, and we use AMUs next to that number. So one atom of carbon has a mass of 12.01 AMUs, or we can think about it in terms of moles, and then we use grams. So 1 mole of carbon atoms has a total mass of 12.01 grams. All right. So to determine the molar mass of any substance on the periodic table, you just need to go look at that number. All right. If it's an atom, or sorry, if it's an element, it's very straightforward. But what if it is instead a molecule? All right. So down below, I have 3 boxes which has 3 molecules. So if I want to calculate the molar mass of a molecule, I need to take the molar mass of each element in that molecule and the number of each element, and then I need to add them up. All right, so I'm going to do this for these 3 molecules. Now, initially, you're probably going to have to write these out as you're working through them. But as you get more and more practice, this is one of those skills that you tend to start doing just on your calculator. You don't really write it down. But initially, we probably should write out what we're doing just so we really understand what's going on. All right, so here we have water. So we have two elements, hydrogen and oxygen. Looking at those subscripts, I have two hydrogen atoms. And if I go look at the periodic table, each one has a mass of 1.01. So if I multiply those two together, I get 2.02 grams per mole for the hydrogen atoms in that molecule. For oxygen, I have one, and each one of those has a mass of 16 grams per mole. So if I multiply that out, I get 16.00. Then I'm going to add those two things together, and I find 1 mole of water has a mass of 18.02 grams per mole. So our unit here is a compound unit, grams per mole. All right. You need to have both pieces when you list the molar mass. Don't just put grams. It is grams per mole. All right. Let's move on to CH3NH2. This time we have three elements, CH and N. I have one carbon with a mass of 12.01. And then I have 5 hydrogens, each at 1.01. And then I have one nitrogen at 14.01. I'm going to add those up, and I get an overall mass of 31.07 grams per mole. All right, again, do not forget the unit. It's really important because we're going to talk about how to use that as a conversion factor in just a few minutes. All right, now next I have a compound AlNO3 3. All right, and the tricky part here is this outer 3. You need to distribute that into the elements inside of those parentheses by multiplication. All right, so what does that mean? All right, we have aluminum, nitrogen, and oxygen. All right, that 3 does not affect the aluminum. It's not right next to it. It's not outside of a parentheses with aluminum inside. So we only have one aluminum atom that has a mass of 26.98. All right. And then for nitrogen, we have one nitrogen inside the parentheses and then 3 of those NO3 groups. So we have 3 total nitrogen atoms here. So 14.01 times 3 is 42.03. All right, for oxygen, each NO3 molecule has 3 oxygens, and then I have 3 of them. So 3 times 3, we have 9 oxygen atoms. So that's going to be 16 each for 144. Then we're going to add those up, and this is 213.01 grams per mole. All right. So again, that compound unit is very, very important. All right. So you should be able to calculate the molar mass of any substance that I give you as long as you have a periodic table and a calculator. Just remember, if there are parentheses inside your molecule and there's a subscript outside, you need to distribute that by multiplying all of the subscripts inside by that number. Okay. All right, so let's go back to this back page and talk a little bit about how to convert between moles and grams. All right, so before we had a unit equality where 1 mole of the substance was 6.02 times 10 to the 23rd particles. All right, this time we're going to say that 1 mole of any substance is equal to that substance molar mass, which we represent as mm, in grams. All right, so when we say grams per mole, it's grams per 1 mole. All right, so 1 mole of any substance equals the molar mass of that substance in grams. All right, so how do we use that? All right, well, first we're going to go from moles to grams, and just like we saw before, all right, we're going to have a value that is given in the problem. Right? And in this case, it's going to be some sort of moles of a substance. All right. And our job is to convert that over to grams. All right. So first, I need this unit, moles of that substance in the bottom, which is going to put grams of that substance in the top. And this is where we're going to use our unit equality, where 1 mole of any substance is equal to its molar mass in grams. All right, now it depends on what the substance is. So that molar mass is actually going to vary from problem to problem. All right, so if we set it up this way, the moles are going to cancel and we're left with grams of that substance. All right, the other option is to start with grams and go to moles. So in this case, we'll have some mass of a substance given in the problem. And that's going to go here. And then this unit is going to go in the bottom. So grams of A will be the bottom, moles of A will be up top. And again, we're going to use that molar mass, where 1 mole of any substance is equal to its molar mass in grams. That'll let us cancel those grams, and we're going to be left with moles of that substance. Okay? All right, so let's try a couple problems with that in mind. Let me go back to the right page. All right, for this first problem, what is the mass of 0.89 moles of CaCl2? All right, so we've got 0.89 moles of CaCl2, and we're asked to convert that into grams of CaCl2. All right, so we have the same substance on both sides, and we've got the mole already. So if I want to go from moles to grams, I'm going to need the molar mass of CaCl2 to make that conversion. All right, and this is going to be a one-step problem, just like what we saw before. All right, so I'm going to calculate the molar mass of CaCl2. So I have 1 calcium, that's 40.08 grams per mole, plus 2 chlorines at 35.45 grams per mole. And if I put all that in my calculator, I'm going to end up with a molar mass of 110.98 grams per mole. All right, so that's my molar mass. All right, so I start with what I've been given. So 0.89 moles of CaCl2. And I set up my conversion factor. I'm going to put this in the bottom. So moles of CaCl2 will be in the bottom of my conversion factor. And I'm trying to find grams. So that's going to go in the top. All right. The way it works is 1 mole of any substance is equal to its molar mass in grams. So 1 mole of CaCl2 has a mass of 110.98 grams. That's going to let me cancel my moles of CaCl2 and leave me with grams in terms of my unit. All right, and this is going to be 98.8 grams of CaCl2. All right, so again, going from moles to grams, moles in the bottom, grams up top. All right, let's look at this next one. How many moles of PbSO4 are in 158.1 grams of PbSO4? All right, so this time I have 158.1 grams PbSO4, and I'm asked to calculate the number of moles of PbSO4 I have. All right, so again, I'm going from grams to moles. So that means I need the molar mass of PbSO4 to finish this conversion. All right, so I need to calculate that. All right, so I have 1 lead, which is 207.2 grams per mole, plus 1 sulfur at 32.07 grams per mole, plus 4 oxygens at 16 grams per mole each. All right, so I put all that in my calculator, multiply it out, and I get the total mass for 1 mole of this substance is 303.27 grams per mole. Okay, so now I set up my problem. I start with what I've been given, 150, ooh, sorry, 8.1 grams PbSO4. All right, my conversion factor is going to put that unit in the bottom, grams for PbSO4. I'd like to take just a moment to mention, you guys notice I keep putting the compound symbol in with my unit. All right, that is very important. All right, as we move into reactions, you have to do that because we're going to change chemical compounds. So you make sure you get in the habit now. All right, sorry, that was an aside. All right, so grams of PbSO4 in the bottom, moles of PbSO4 up top, and 1 mole of any substance is equal to its molar mass in grams. So 1 mole of PbSO4 has a mass of 303.27 grams. So my grams are going to cancel. I do the division and I find that I have 0.51, oops, nope, 521 moles of PbSO4. All right, last one, find the mass of 1.112 moles of HF. All right, so I've been given 1.112 moles of HF, and I need to calculate the mass of that amount of moles. So I'm going to need the molar mass of HF to make that happen. All right, so if I look at HF, it's 1.01 grams per mole plus 19.00, so I'm going to get 20.01 grams per mole as the molar mass of HF. All right, now I start with what I've been given, 1.112 moles of HF, and I'm going to use my conversion factor by putting those moles of HF in the bottom and grams of HF up top. All right. And according to my calculation, 1 mole of HF has a mass of 20.01 grams. It's going to let me cancel those moles. I do my multiplication and I have 22.3 grams of HF if I have 1.112 moles. Okay, so when we convert between mass and moles, we need the molar mass of our substance. And remember, the molar mass is 1 mole of any substance has a mass equal to that molar mass in grams. So that's what lets us set up our conversion factor that we can then use for our unit cancellation. All right, so a little trickier than the particles to moles because we don't have Avogadro's number where we use the same number over and over and over again. Instead, we have to calculate the molar mass for each substance. But I think you guys could do it. I have faith. All right. If you have questions, please let me know.